JUnit as a habit, not an afterthought. JUnit Extension Model. Lab 6 Overview. JUnit Extension Model. The goal of Lab 6 is to teach you how to compose JUnit extensions. This is a complicated lab, an advanced topic, and this requires your sharp attention and even dedication. The code for the utility library is available from the course's GitHub account at https://www.github.com/antongolovin-github/GRG-001 JUnit as a habit. You should have the code for the utility library downloaded as of Lab 1. No changes are needed for Lab 6. We will explore the following topics in this lab. Before all callback, add before all, lifecycle method execution exception handler, add handle before all method execution exception, that's the method name. Before each callback, add before each, lifecycle method execution exception handler, handle before each method execution exception, that's the method name. Anything after the pound in Java notation is the name of the method. Anything before the pound is the name of the class. Before test execution callback, add test execution exception handler. After test execution callback, add after each, lifecycle method execution exception handler, method name handle after each method execution exception. After each callback, add after all, lifecycle method execution exception handler, handle after all method execution exception after all callback. We will also explore add extend with, add register with, automatic registration of extensions with java.util.serviceloader class, execution condition interface, test instance factory interface, test watcher interface, and invocation interceptor interface. And we'll also explore the parameter resolver interface. All right, let us get started. So in beginning lab number 6, some congratulations are in order because we are have been more and more getting into an area of JUnit, which makes you a JUnit guru, which is always very good for you. So let us take a look at everything that we have. Here now we are going to put the files for lab number 6 into tag.getRealGood.util.test package as usual. We are going to also create one more package and put one more file in it. Then we are going to basically get a second project that we must have that already has all the extension code functionality that we will need in this our main project, and we are going to juggle two projects for lab number 6. But prior to that, let us go to File, let us go to Settings, let us go to System Settings, and let's check in the project space. Let's check that the open project in says ask, because we will need the IDE to ask us how it wants to open the second project. The second project we wanted to open in a new IDE window. All right, so let's go forward. Let us go to the project website at grg-001.courses.antongolovin.com, and you see that I have made certain changes already, preparing for the release of this course. Let us go to unit test code, objects tests.java, lab number 6. And let's take a look at the unified diff. This is basically the difference that we are going to see in lab number 6, and the difference is not vis-a-vis lab number 5, but the difference is vis-a-vis lab number 1. And you see here, for example, that we don't have difference versus in lab number 5 we didn't have difference versus lab number 1. Let's wait just 1 second. If you recall, in lab number 5 our files were the same in lab as they were in lab number 1. In lab number 6, however, they are slightly different from lab number 1, and that's the unified diff that we are seeing. Alright, so that's a good place to study the differences. Let's go to math-test.java and see the difference for lab number 6 from lab number 1. Let's take a look at that. We have some differences here. Well, these are not related to, strictly speaking, lab number 6. They're related to the fact that we had a little bit of a minor issue with the compiler not recognizing this as a double. And so, if you recall, throughout our course we've been changing that, and this we just added the add before all and add after all lifecycle methods. Let's take a look at collections tests. Here also we have very few meaningful changes, and arrays tests as well. We have very few changes which are related to the subject matter of lab number 6. So the majority of our functionality for lab number 6 is going to be found in the objects test.java and strings tests.java. You see that we are importing the annotation at extend with, at register extension. We are basically, they're commented out now, but all the extensions that we have created, I already put into the code. I just commented them all out for convenience. Here at register extension, we'll need to have a constructor for objects tests which passes in a logger, so that we can, for example, take advantage of the loggable objects test factory extension, etc. So lots of interesting things. Test result watcher, etc., etc., etc. So that's for objects tests. For strings tests, a slightly different picture. Here we are using a method named parameter resolver. Parameter resolvers are always very useful and fun. The parameter we're resolving is this string. We're getting it from somewhere and injecting it into this method. You see the method is commented out because we will comment it in when the time comes for us to actually describe how the parameter resolver works. The add invoke twice custom annotation that we did by using the add test template, it's very interesting. So that's what's in strings tests. And just to rehash whether we have anything in mass tests, no, we don't. So All the functionality of lab number 6 is located in objects tests and strings tests. However, for the sake of completeness, we will utilize all the 5 classes. So in the next video clip, we are going to add these classes into our IDE, into the package tag.getRealGood.util.test. In this video clip, we are going to create the test files we need for lab 6. Let's go to the project website, unit test code, objects test.java, lab 6. Let's scroll down to full file. Let's click on copy. Let's go back to our IDE and create this class called objects tests. All right. We don't want to do that. Let's delete what was auto-generated, and let's place what we copied into objects tests.java. All right, don't worry about this yet. We'll get it done. Let's go back to the project website. Let's go to strings tests.java. Let's go to lab number 6. And let's scroll down to the full file. Let's click copy. Let's go back to the IDE. Let's create strings tests. Then let's paste what we have in here. Also, don't worry if you notice any errors popping up. Well, here there aren't any. All right. Let's go back to the courses website. Let's go back to math-tests.java, lab 6. Please recall that the remaining 3 files do not have any changes relevant to per se lab number 6. So we're just going to create them because we've always created 5 files. All right, let's go back to the project website. 2 classes should be remaining. Let's go to collections test.java, lab number 6. Let's scroll down to full file. Let's go back to the IDE. Let's create collections tests class. Let's paste what we have in here. Then let's go back again to the courses website. Let's go to arrays tests.java. Let's go to lab number 6. And let's go to full file. Let's copy it and let's create the 5th test class. Arrays tests. Let's paste what we have in there. All right, and we are good to go with this video clip. We have created the 5 unit tests. Objects tests, 5 test classes. Objects tests will have this error, which we will fix in the next video clip. So now, having created the test classes, let us go back to the project website. Let's reload it. It's a 1-page kind of project website, so it's about 1 megabyte of data. Most of it is the code that Prism.js will parse. So having reloaded it, let's go to extension code. We are in lab 6, so we need the extension code. So let's do step 1. These following files must be copied for lab 6 into the tech.getRealGood.util.ext package of the GRG-001 JUnit as a habit project. So let us create this package. If you recall, that's exactly the package that objects test class is showing as missing. Alright, let's create this new package. tech.getRealGood.util.ext. Alright, so now it's showing that it's available. And going back to the project website, we need to create a file called loggableobjects.testfactory.java within this project, which we will do right now. Alright, and let's go back to the project website again, and let's copy this file. And let's go back and let's paste the contents of this file into loggable objects test factory. Okay, it should be tests, but here it's test. So rename file. Alright, and we are good. So we have imported the extension that we need to be within the main project that we have. Now let's try to build it to make sure that everything builds fine. Alright, and it builds fine. So in the next video clip, we are going to import a new project called GRG-001 JUnit as a habit extension into our workspace, if you will. So we are going from having a main project to having a main project and one auxiliary project. Alright, thank you for your attention, and I'll see you back in the next video clip. Alright, so having created the loggable objects test factory extension class, let us now go back to the project website and let us go to step 2. You can either clone or download the GRG-001 JUnit as a habit extension project. Well, and here I note that yes, the projects are multiplying out of necessity. Over the course of labs 6 and 7, we are going to keep our main project, but we're also going to create 3 auxiliary projects to keep our code base for our course neatly organized and much more manageable if we put everything into the same project. For example, in lab number 7, we're going to create a test engine, and that one we just must put in its own separate project because it's a totally separate thing from our test class code. Alright, so let's clone this auxiliary project. Copy link. Let's go back to the IDE, and here always here on top you can always see the name of the project we're working on. Let's go to File, New Project from Version Control, Git. Let's paste this URL. Let's put it in the same under the same general directory as our main project, and let's do clone. Alright, it's cloning. Alright, now it's gonna ask us how we would like to open the project. And what we always want to do, we always want to open it in a new window. So it's preparing the workspace. Alright, so it's opened the project. We can see that it has some new stuff. For example, we're putting something within the meta.inf folder, so that should tell you that we are going to prepare a jar file out of this project. Right, external libraries, etc., etc. Alright, so now we have two windows open. The first one is our main project, and the second one is our extension project. Let's go into the project structure for the extension project, and let's see that our project is not missing some relevant dependencies. So we are still using the same JDK. Let's go to modules. All right, our modules are correct. Let's go to libraries. The library is correct because we, in our main project, the JUnit Jupyter library, JUnit 5 library, we deployed it into a central Maven repository. So our auxiliary project was able to find it. If our auxiliary project was not able to find it, for example, we had downloaded it to a local location for our main project, then what we would do, we would go from Maven, we would copy this string, and we would just create, download the library. If the dependency was broken, we would download the library and fix the dependency that way. But in our case, it was, you see, WM2, so we know exactly it's a central Maven repository on our hard drive. And in this case, our auxiliary project was able to find everything just fine. Now let's go to artifacts, because what we want to do is we want to output this auxiliary project as a jar file. And we need to do something with the meta.inf services folder, because that is how we can use the service loader mechanism. If you recall from the lecture number 6, we can use a service loader mechanism to automatically register an extension. And we are placing this file, and within that file, we are basically providing a fully qualified class name of an extension class that we want to automatically register via the JVM service loader mechanism. So we need to check that our jar has the ability to create the meta.inf. Within the meta.inf, it will create the services folder, and within the services folder, it will add this org.junit.jupyter.api.extension file. All right, everything looks good. So we have the correct SDK. Our modules look good. Our libraries are found, and we have a jar artifact that will be created on compile already. So everything is good. Let's now go ahead and let's rebuild the project and see that everything builds correctly and that we're getting the jar file also generated. Alright, we got the out folder, artifact, and we do have the jar file. It was properly generated. Now let's do this. Let's go here. Let's select copy path, and let's select the absolute path. In your case, the absolute path may be different, especially if you run Linux, it will look very different. If you run Windows, it will look similar, but probably have different directory names. So let's create the absolute path, copy the absolute path. let us go to our main project, GRG-001 JUnit as a habit, and let us go to File, Project Structure, and let us add this newly created jar library. Here it is. We are going to add it to our project. So this jar library, if you recall, it contains the code that we need for extensions that we're going to use in lab number 6. All right, let's review our main project. We're using the right SDK. We're using the right modules. We have the JUnit 5 library. We have the extension jar library, and we are creating no artifacts. All right, so everything's good. Now let's try to rebuild our main project, and let's see that everything builds fine. All right, and we are good to go. We have successfully set up our workspace for lab number 6, and in the next video clip we'll get started on exploring the various types of extensions that JUnit 5 provides for us. Alright, so now that we have configured our main project and our auxiliary project, we are ready to review the extension classes. Let's start with loggable objects tests factory. Alright, so here we see that it implements test instance factory, and we override the create test instance method. So you should spend a little bit of time just to kind of browse this code. More in-depth browsing will take place when we actually go through the various types of extensions. Now let's go to the classes which are part of our auxiliary project. First class is called disabled method execution condition, and basically it implements execution condition, which is an interface that implements extension interface, which is a marker interface that tells the JUnit runtime that this is an extension, and we override the evaluate execution condition method. Next is enabled method execution condition. Just like disabled method execution condition, what this class does, if we annotate a method with the @extendWith, and in the parenthesis enabled method execution condition.class, this will basically enable the execution of this method, and this will disable the execution of the thus annotated method. And we again do evaluate execution condition, and here we return the condition evaluation result that enabled or that disabled. Alright, next is an annotation called invoke twice. We are actually going to do an annotation invoke twice, and the method that we annotate with @invoke twice will be run exactly 2 times. So you can see here that we're using the @test template annotation that was part of lecture 5, but we deferred the lab for the @test template annotation to lab number 6. And for this precise reason, it's a type of extension, you always use it with the @extend with annotation. In our case, it's invoke twice extension dot class. So let's go further. Invoke twice extension dot java is a class that implements test template invocation context provider. See the test template wording in here. And we override two methods here. The supports test template and provide test template invocation contexts. All right. So now we know that we must provide an invoke twice invocation context as well. That is something, that is a class we must create as part of creating our custom annotation, taking advantage of the add test template paradigm. All right, invoke twice invocation context implements test template invocation context. Notice test template here. And we override one method, get display name. So that when we get the results of our run, that is what would be returned as the name of the run. All right, and of course, further we'll delve into it when we'll be actually working with this type of extension in later video clips. Now, method name parameter resolver annotation implements the very important parameter resolver interface. So parameter resolver interface is an interface that allows you to inject parameters into your unit test methods and in general into various parts of your testing setup. So here we are overriding two methods, support parameter and resolve parameter. So whatever method we are going to annotate with, whatever unit test method we're going to annotate with extend with method name parameter resolver that class is going to have their parameter or parameters injected with whatever we come up with here. All right, in this case, it's the name of the method which we annotated with the extend with method name parameter resolver that class. So not very inventive or imaginative, but good enough for our purposes. All right, next is type timing extension .java. It's an extension that is applicable to a test class that or a nested class that basically collects the total number of milliseconds the contained unit test methods take to run. And here you can see that we implement before all callback, after all callback, and lifecycle method execution exception handler interfaces. And as a result, we implement some methods that we override from the interface. All right, we implement before all, we implement handle before all method execution exception, we implement after all, and we implement handle after all method execution exception. All right. Now, in our auxiliary project, type timing extension works in concert with the method timing extension, and as the method timing extension suggests, it's something that is applicable to a unit test method, and it figures out how many milliseconds a unit test method took to run. All right, and it implements before test execution callback, after test execution callback, lifecycle method execution exception handler, and test execution exception handler. And as the result, we implement handle before each method execution exception, before test execution, handle test execution exception, after test execution, and I think that's it. Also we are forced to use the concept of a store. Remember that each extension context comes with an inner class called store. And the store is nothing else than a hash map or some other form of map, it doesn't really matter, within which we can store key value pairs to be passed around between various extension invocations. We can use the store of a particular extension, we can get a parent extensions store, we can get a global a top level store as well if we want to pass values between extensions, a test level, test class level extension, or a unit test method level extension. They can communicate by using a global extension. For example, if their relationship is not clear, if we know that one is the parent of another, we can get the parent store. But if we don't really know, or if there are several levels of kind of parenthood, then we can use the global store object. All right. Store constants is just a utility class. I could have easily put the total time within as a static variable within the type timing extension, but I just did it as a separate class. Alright, the next is test invocation interceptor extension, and here we basically implement the invocation interceptor, and we have a chance to basically inject some functionality. For example, before test class constructor, before the before all method, before the before each method, before the unit test method, before a test factory method, before a test template method, before a dynamic test, before the after each method, after all method. So we can do quite a few types of interceptions of method invocations, and once we, for example, placed our custom logic before it, we can do invocation proceed for the actual real method to be called. So it's quite powerful. It doesn't just focus on lifecycle methods. It can intercept a test factory method. It can intercept test template annotated method. It can intercept a dynamic test. If you recall from lecture 5 and lab number 5, our study of dynamic tests, etc. And of course, all the usual lifecycle methods. All right, the next type of extension is the test result watcher, which implements test watcher. And we have here test disabled. If a test is disabled, this functionality is run. Test successful. If a test is successful, this functionality is run. Test aborted. If a test is aborted for whatever reason, this functionality is run. Whatever we put in here. Test failed. If the test failed, then this functionality is run, whatever we put in here. So it's a nice, nifty extension that watches the results of our test execution and reacts accordingly. All right, next is funny message extension. Well, funny message extension is something that I just created so that I could show you how to register an extension static as a static variable by using the @register annotation. Actually, let me be more precise. Alright, where did I put this? Yes, it's here. Alright, so it's coming, everything's commented out. I'll be commenting it back in as needed. So register extension annotation registers the extension kind of in code, and it has the advantage over the extend with annotation in that you could, after you register it, so you could basically modify it within the actual test class where you're registering it in. Alright, so here we have not funny message extension and not funny method message extension. That one I register as a static variable which is applicable to the test class, and the other one I register as an instance variable which is applicable to unit test methods. Alright, but here we have the funny message extension, and the funny message extension I actually implement, and my apologies, I kind of forgot about it for a second. Funny message extension I actually implement as a automatically registered extension by using the service loader mechanism of JVM that JUnit 5 takes advantage of. So funny message extension is automatically registered by JUnit 5. Alright, and of course not funny message extension and not funny message method, not funny method message extension are registered by using the @register extension annotations. And there are, as I explained before, two ways to register it. At the test class level, you do a static variable. At the unit test method level, you do an instance variable. Alright, that concludes our review of the types of extensions provided by the JUnit 5 runtime, and we are in the next video clip are going to get started exploring various types of extensions. So let's get started with lab number 6. We're going to start by exploring a combination of a type timing extension and the method timing extension. Let's take a look at objects tests.java, and you will see here that we have a commented out that extend with type timing extension. Then as we go forward to unit test classes, we have @extend with method timing extension, @extend with method timing extension, @extend with method timing extension, and @extend with method timing extension. So we have 4 unit test methods, 4 method timing extensions. Please notice that these 4 unit test methods are encapsulated within 2 nested classes. And please notice that we have @extend with type timing extension declared at the test method level. Alright, let us go ahead and let us uncomment the @extend with method timing extension class annotations, and let's see what happens when we run our unit tests. Right click on objects tests, select run objects tests. Let's wait a little bit for the build, and let's see what happens when we run it. Alright, you can see that we have run first is not null underscore common underscore object underscore boolean, which you can see here. That is the first which ran. It took 28 milliseconds. The second one which we ran took 3 milliseconds. The third one which we ran took 2 milliseconds. And the fourth one which we ran took 0 milliseconds due to the platform heating up a little bit. Alright, in total we can see where the log is compounded on the objects test class level. We see that the system clearly worked well. Our extensions were recognized. You can see that it says tag.getRealGood.util.ext.method timing extension. And basically, we were able to calculate how much time the running of each unit test method took. Now that we have seen that the extension worked as it should, let us control click on the extension. You see that the decompiler does its job. Alternatively, we could have switched to the other project, GRG-001 JUnit as a habit extension, and we could have went into the tag.getRealGood.util.ext package, and we could have opened this extension this way. So let's take a look at actually what we are presented with. So basically we're declaring a start time and an end time, we're declaring a logger, and we are declaring a private method getStore, in which case we are declaring a store under the name of method timing extension. So kind of in situ store that we can use to store values between invocations of this extension. Alright, so we have several methods: handle before each method execution exception, before test execution, where we create the start time variable and put it in the store. Handle test execution exception. Well, in these cases where we have to handle the exception, we just rethrow it. Then we have after test execution, where we sample the end time and we put the end time into the local store. Then we get the start time, the end time, we calculate the total local runtime, we log it, and then we do something which will be apparent a little bit later, because we put the total time. Actually, we either augment the total time, we get the total time from the global namespace, from the global store. We either augment the total time or we initialize the total time if it's our first method which we run. And we put it back into the global store. So that's what method timing extension does, and it's quite simple. Now let's look at the extension which we decided to pair it with, which is going to be, let's close this. Let's actually from now on not decompile the extension from this jar which we placed into as a dependent library into our main project, but let's go to the auxiliary project from now on to take a look at the code. Alright, so now that we have seen the method timing extension working fine, let us uncomment the type timing extension. And let's run objects tests one more time and see what it does. Alright, we can see that just as before, we have the first method took a little bit less, 18 milliseconds. The second took 3 milliseconds, the third took 1 milliseconds, and the fourth took 0 milliseconds. Alright. So basically, what we have here is the beginning of the interaction between the type timing extension and the method timing extension. The method timing extension worked as before. It basically just calculated how much it took us to run the 4 unit tests. The type timing extension, however, did not work as expected, so it did not run just once. It ran actually once, stating that the isNotNull inner class took 21 milliseconds, 18 plus 3 to run. It ran the second time, stating that when we ran the isNull inner class, the compounded or the augmented total time it took to run was 22 milliseconds. So 18 plus 3 is 21, plus 1 plus 0 is 22. So once we ran the isNotNull inner class, it took 21 milliseconds. Once we ran isNotNull and isNull inner classes together, it took in total 22 milliseconds to complete. And it ran also a third time, not surprisingly, well, those two were surprising, you would think. The third time it ran for objects tests. And it told us that the totality of the runtime for all the unit tests, either top-level unit tests or for all the unit tests within nested classes, was 22 milliseconds, which is what we would expect. So remember that the test level type timing extension not only runs for the top level class, but it runs for the internal and nested classes, each time providing the total cumulative time it took so far. Alright, let us switch to our auxiliary project. Let us find the type timing extension and let's study it. So it implements before all callback, after all callback, lifecycle method execution exception handler. We have the logger, which we just saw the output of the logger. We override before all, or implement before all. We implement handle before all method execution exception. We implement after all, and we implement handle after all method execution exception. All right. So at before all, we basically say that if there is nothing, there is no key total time in the global store, then create that key with the value of 0. And after all, it just says get the total time from this key, and if the total time exists, then output it, which we saw this output here, but we also saw it here for add nested classes and here. Alright, so that is how our type timing extension and method timing extension work and how they cooperate. Now let's take a look at before all callback interface actually. And we see that the interface before all callback extends extension, and let's take a look at extension. It's just a marker interface telling the runtime that implementing interfaces in classes are parts of the extension mechanism. All right, let's take a look at the after all callback. Same picture. Please notice that these methods must be implemented. They are not default. Let's take a look at lifecycle method execution exception handler. Here we see slightly different picture because we see that we don't have to implement anything at all if we decide to implement this interface, because the methods are default. And by default, they just rethrow whatever exceptions they get. So default, etc. All right, and same for method timing extension before test execution callback. Also must be implemented, extends extension. After test execution callback must be implemented, extends extension. Here we have default methods that don't have to be implemented, they just rethrow the exception. And here we have a method that must be implemented, and this interface also extends extension. Alright, so far so good, fairly simple. The only more or less complicated part is the extension context.store object. Let's take a look at it. It's just a second. Interface, and you have the get method, you have the get to default, you have the get to computer absent, etc., etc. So it's basically a little bit more than a glorified map. You have the put method, remove, you have the namespace class, you have the global namespace for the object class, etc. So basically, and we have the interface extension context as well. So get parent, get root, get unique ID, get display name, get tags, get element, get test class, get required test class, get test instance lifecycle, get test instance, etc. All this, please notice that this return optional of an object. Get required test instance, etc. Which gets the required test instance associated with the current test container. You might want to, when you're browsing, you might want to, oh, wait a second. You might want to enable the reader mode. You would see it like this. If you enable the reader mode, you will see it in a more readable case. So I encourage you to spend some time actually on the extension context interface, on the store interface, on the namespace interface, and just read the comments and what each particular method does. So spend maybe 5-10 minutes on this. Right? By pausing the narration, you can just spend some time, and then you're good to go to continue the narration. All right, that completes our video clip regarding the interplay and interaction of various extensions, type timing extension and method timing extension in this case. So in this video clip, we're going to study the loggable objects tests factory type of extension. Let us take a look at the objects test.java. first order of business, we need to comment back the type timing extension and the method timing extension, directives, statements. All right, that's what we're going to do. And then we're going to uncomment the extend with loggable objects factory, loggable objects test factory.class. And we need to comment out the default constructor, no arguments constructor. And we need to comment in the constructor which allows us to pass in an instance of a logger. And we need to go to loggable objects test factory, and here we need to comment out what returns the default constructor to the one which returns the logger constructor. And obviously we did this because we needed it to compile, our project to compile, when even we had the non-default constructor commented out and the extension itself commented out. All right, let's build it and see that it builds correctly. And it does. Now is the time to run the objects tests test class and to see whether this works correctly. Right, everything works correctly, but we see here that create test instance was called for objects tests and then is not null, objects tests and then is not null. So it was running the two unit test methods here, and because we have the per method semantics, we get a fresh copy of the test class and the nested inner class for each unit test. And the same picture for here object tests is null inner class, object tests is null inner class. And then here what I did, I added the log.info for the is null underscore common underscore object underscore boolean unit test method. And that's exactly what was output here, proving that the log variable was injected into the constructor here, because here we do not initialize it. All right, let's take a look at the loggable objects test factory.java. Here we see the create test instance. We pass in a copy of the test instance factory context and extension context. We declare an instance of our logger variable with the objects tests.class. Then basically we separate the top level class, which the code is here, and add nested inner class, in which case we create the new instance slightly differently. So that's how that's one way in which test instance factory extension works. Let's take a look actually at this extension, at this interface, and basically it extends the extension, so the runtime knows it's an extension, and basically we have to implement only one method, create test instance, and we can use test instance factory context, which you can see is an interface itself, or an extension context, which is an interface itself, and you're free to freeze the progression of the course and to study these two interfaces, what they contain. Just make sure you switch your editor to reader mode so that it's easier for you to read the Java doc. Right, this concludes our expose of the loggable objects test factory extension, which is an instance of a test instance factory. What this extension again does, it helps you custom create an instance of a test class. In our case, we just injected a logger instance in here, but it could be many things. It could be objects from a framework you're trying to test. It could be objects from a library you're trying to test, etc. It could be anything. So in the next video clip, we're going to take a look at the test invocation interceptor extension. In the meanwhile, let us clean up what we did in this video clip. Let's uncomment the default constructor here. Let's comment out the constructor, the parameterized constructor, and let's also comment out this line. By the way, I did insert this line into the code. It was not a part of the code that we picked up of the course's website. So you would do the same thing. All right. So we are done with this course. I mean, with this class, and let's do it like this here. Let's see that we're able to build it just fine. Alright, and we cleaned it up just fine. So in the next video clip, we're going to do the test invocation interceptor. In this video clip, we're going to explore the test invocation interceptor extension. Go to line 14 of your objects test.java and comment out the test invocation interceptor line. Now let us switch to the auxiliary project and let us take a look at the test invocation interceptor. You will notice it implements invocation interceptor, so let's click on that. Make sure you're in reader mode. And we see that it is an interface which extends the extension interface. And we see that this interface has a lot of default methods, such as intercept test class constructor, which is kind of a self-explanatory, intercept before all method, intercept before each method, intercept test method, intercept test factory method, such as the one we saw in our previous video clip, intercept test template method. We could create a construct based on the add test template annotation, and that is what it would be used for. Intercept dynamic test. You remember from lecture 5 and lab 5 that we can create dynamic tests. This is what this method would do. Intercept after each method, intercept after all method, and we also have an interface, an inner interface invocation, which represents the invocation of the actual method that we are intercepting. So you're welcome to freeze the progression of the course and to study this interface being in reader mode, so you can read the Java docs more or less easily. Alright, let's take a look at the test invocation interceptor, which is our implementation of the invocation interceptor. And just for clarity's sake, I chose to implement all the methods, even though we do not need, in what we are using it for, we do not need to implement all the methods, just a few of them we need. And so I'm basically just logging what this intercepting method is doing, and then I'm instructing the runtime to invoke the actual method we're intercepting. And that is everywhere like that. So invocation context.getExecutable.getName just gets us the name of the method which we are intercepting. Okay, let us switch back to our main project and let us run first of all, let us try to build it to see that everything builds okay. Everything built just fine. So now let us run objects tests, all the tests, and let's see what log output we're going to get here. Alright, so in the objects test we have the add before all method, add after all method, add before each method, add after each method, and we have add before each and add after each in the inner classes, and we have the unit test methods. So here we got a whole bunch of output. We have a statement from the test invocation interceptor that it's intercepting before all method. Then it is intercepting test class constructor. It is again intercepting test class constructor for the is not null inner class. It is doing the same again for objects tests. For is not null, because remember we are in the per method semantics, so for each run of the unit tests we need one fresh copy of both our top level test class and a add nested inner class. Then we have an interception of the before each method, intercept test method. Then before each method we have, because we have a top level before each and an inner add nested class before each. Then we have a add nested class after each and a top level after each. And the same happens for the second. The same happens for the second unit test method of the is not null add nested test class. So basically we've got two instantiations of objects tests, two instantiations of is not null as we would expect, and then we had the instantiations of both unit test methods. And the same thing for the is null, or of the add nested is null class. Again, objects tests is null, objects tests is null, first unit test, test method after each, and the second unit test of the add nested is null method. Alright, and then we have the interception of the after all method, and we are done. You're very welcome to freeze the progression of the course to study exactly the output of in this log window, if you are even in the least not 100% clear what is happening here. Alright, so that illustrates at least in part how we would use the invocation interceptor of any kind. Of course, it is very varied. It can intercept not only unit tests or lifecycle methods or test class constructors. It can also intercept dynamic tests. It can intercept at test template methods, such as in here. It can intercept test factory methods. So it is a very powerful and varied type of interceptions. The only thing to remember, if we do not want to call the actual methods we are intercepting, then we should not call invocation.proceed. And in some cases we return the invocation.proceed, in some cases we just invoke it, depending on the return type of the method. Alright, so I think we are done for this particular type of extension. We have seen so far 3 types of extensions. Type timing extension and method timing extensions, of course, are test class level extension and method level extensions that cooperate with each other. Loggable objects tests factory extension was a extension that allowed us to instantiate custom test class instances. And test invocation interceptor is an extension that allows us to intercept invocations of constructors and methods of various types, including lifecycle, unit test, dynamic test, at test template, and custom test instantiations. In the next video clip, we're going to take a look at a type of extension that we're calling test result watcher, that basically can run certain code based on a unit test lifecycle events within the running of the unit tests. I don't mean that before all, that after all, before each, and after each. It doesn't apply to that. But there are certain hooks within the running of a unit test, such as the result of the run of the unit test, that can be addressed by the test result watcher extension. So I think we fixed everything here. Let's see that it builds correctly before we go on to the next video clip. Alright, and we are good to go. In this video clip, we are going to take a look at another type of extension which we implemented as test result watcher. Let us switch to our auxiliary project and take a look at the test result watcher class, which implements the test watcher interface. So the test watcher interface features a series of default interface methods: test disabled, which is invoked when a unit test is disabled; test successful, which is invoked when the unit test is successful; test aborted, which is invoked when a unit test is aborted; and test failed, which is invoked when a test fails. In the default implementations, they're all no-ops. And I chose to implement them to just log output of basically the event which caused them to run. Alright, test disabled, test successful, test aborted, test failed. Let us switch back to the main project. Let us uncomment at extend with test result watcher.class, and let us run this method. And we can see that test result watcher test successful method is run, and it outputs that we successfully ran the unit test. It succeeded. Alright, well, let's delete this. This was from previous, oh, pardon me. This was from previous video clip. So we have seen what happens, what event is raised of the test watcher interface when the test successfully completes, which method runs. Now let's make it fail. And let's see. Alright, so now we have an assertion failed error, and our test result watcher class says that the test failed method is run, and it outputs the log message that we input within the test failed method. Right, let's return it to true, and let's add the disabled annotation. Let's add the disabled annotation and let's run it. And what we get is not quite what we expected. We got that it successfully ran. However, we have the disabled annotation here. So what's up? That is an artifact of how JUnit was integrated into our IDE. The IDE simply doesn't pick up at disabled annotation. So in order to pick it up properly, we have to run it at the level of the test class or at the level of the add-nested inner class. And then we will have the correct result. You see that one method is ignored because it's disabled. And we see here that test result watcher test disabled method is called on our unit test. And that it says what we put into the logger, that this method is disabled. Alright, so that is how it works. Obviously, it is a rather simple exposition on how it works. Much more complex logic could be run within those methods of test disabled, test successful, test aborted, and test failed. Right? That concludes our treatment of the test result watcher class implementing the test watcher extension. And let us fix now what we uncommented so that we return everything to its original state. Let's build it, rebuild project. In the next video clip, we are going to explore the enable method execution condition and disable method execution condition extensions, making use of the execution condition built-in extension. Right, so everything successfully compiled. In this video clip, we are going to take a look at the enable method execution condition and disable method execution condition classes implementing the execution condition extension. Let's go to objects tests and let us uncomment the appropriate add extend with annotations. Here you see it's add extend with enabled method execution condition that class. Here it extend with disabled method execution condition that class. Let us take a look at the enabled method execution condition. And so well, actually let's switch to the auxiliary project and let us open it there. Enabled method execution condition. Implements execution condition. So the interface execution condition is an extension, and it provides one method to be implemented by implementing classes. Evaluate execution condition takes an instance of extension context, which is supplied to all the methods of extensions, and it returns condition evaluation result, which is a class that gives you two methods, static methods, enabled and disabled, which returns kind of an instance of itself. That's what we'll be using for this extension. All right, let's take a look at enabled method execution condition. Here we are just saying that whatever's annotated with this is going to be enabled. And here we are saying whatever's annotated with this is going to be disabled. Right, let's go back to our main project and let's run our unit tests. Let's run with the @nested is not null inner class. And we see here that one of the tests passes and one of the tests is ignored. And for the one which is ignored, we get a message that skipping method this because it is annotated with @extend_with disabled method execution condition. Now let's switch to extend with @enabled method execution condition and see if that helps to run both of them. And both of them run just fine. All right, a good use of this, execution condition implementations is to create a custom annotation and place the @extend_with, for example, disabled method execution condition .class on this annotation, and then just use this annotation where you want to disable certain methods. Right, let us return everything into commented out state. Let us build to make sure everything builds correctly. All right, and the build is fine. Wonderful. So in the next video clip, we're going to take a look at method parameter resolver class, which is an implementation of the parameter resolver interface, which is an extension within the JUnit 5 runtime. And parameter resolver is a very important interface. This extension allows us to basically find and inject into methods or constructors, etc., various value subjects, etc. For example, from a framework we might be testing, or from a jar library we might be testing. So it allows us to integrate JUnit 5 into the testing schema for a third-party framework, for some important library that we want to test, etc. In this video clip, we are going to take a look at the parameter resolver interface and our custom implementation called method parameter resolver. For that, let us open the strings tests, the Java test class, and let us navigate to line number 64. So we see at line number 64 is a unit test method that's commented out that's identical to the unit test method which is directly preceding of it. So let us comment out the preceding unit test method, and let us uncomment the currently commented out test method. Alright, here we can press Alt Enter, and we'll import method name parameter resolver from this library here. Alright, let's take a look at method name parameter resolver, but let's do it from our auxiliary class. Let us switch to it, and let us take a look at the method name parameter resolver. You see that it implements two methods, supports parameter and resolve parameter. And it implements parameter resolver interface. Let's take a look at it. A parameter resolver extends extension. So it is an interface which, once implemented, will result in us having made an extension of the JUnit 5 platform. And it has two methods which must be implemented by classes which implement the parameter resolver interface. Supports parameter, which just basically says whether or not a certain parameter is supported, and resolve parameter, which pulls a parameter value either from parameter context or extension context, or we can provide it in a simpler way from something else according to our requirement. In this case, we just say that this parameter is supported, that we are trying to inject into our method, and that the resolve parameter method just basically gets the test method, the unit test method's name of the unit test method, which is annotated with our method parameter name resolver, and just basically returns the string of the name. Alright, so this means that in this case the string, the name of this method, will be fully qualified string of this method. Well, let's check if it's fully qualified. Let's run this. So remember, we are using the value of this method parameter here. So if this value is not supplied by this extension, we are going to get a null pointer exception. Well, let's see how it works. Well, okay, so it's not fully qualified, it's just the basic name of this method. So what this extension did, it looked up the name of this method, it injected the name of this method into the method itself as the value of this parameter, and then it logged it for us to see. So the name of this method is to upper underscore common underscore string underscore string. Right, so that's how the parameter resolver interface helps us in integrating data into our test flow. For example, obviously it doesn't have to be so simple that we get the name of the test method which we're running. It could be something more complicated. Something could be in the store value of the extension context, for example. This parameter resolver interface is how JUnit 5 is integrated, for example, into the Spring frameworks testing, etc. And it could be integrated into any frameworks testing workflow. So let's take a look. We already saw extension context in a previous video clip. Let's take a look at the parameter context. It has the method getParameter, getIndex, getDeclaring executable, which is a default method, getTarget is annotated, etc., etc. And in the reader mode, please spend some time freezing the progression of the course, but spend some time reading basically what these methods do. Find annotation, find repeatable annotations, etc. Alright, so in a somewhat basic but illustrative way, that concludes our treatment of the parameter resolver interface, in our case implemented as a method name parameter resolver class. Let us clean everything up. In this case, we are just going to comment it back out, and let's rebuild the project to see that it actually builds fine. Alright, and everything is good. So in the next video clip, we're going to take a look at the add-invoke-twice annotation, which takes, let me actually show you. If you recall, in lecture 5, we talked about the add test template annotation, but we said we are going to defer it to lab number 6 to explore how it works. Well, this is where we are going to explore it. It works in conjunction with a extension of some sort, and it allows us to make custom annotations and to use a test template and add extend with as a meta annotation to create some interesting and potentially very complex functionality for our testing. For example, add parameterized test and add repeated test work according to this design. Although add repeated test doesn't explicitly use the add test template annotation, it's something that's built into the runtime, but add parameterized test actually uses the add test template annotation. So I will see you in the next video clip. In this video clip, we are going to explore the add test template annotations, applications, and the particular way which we utilized it here. So if you go to strings-test.java, navigate to line 85, and let us basically uncomment the invoke twice annotation, press Alt-Enter so that it is found, and comment out the add test annotation. So add invoke twice annotation will cause this method to be run exactly twice. And how did we get to do this? Let's check. Alright, when we click on the, well, actually let's go to the auxiliary project. Let's open the invoke twice class. When we created the add invoke twice annotation, you will see that basically it can function as a meta annotation, or it can be applicable to a method. It's retained at runtime. Well, here we can, it's an artifact of something else. We can safely delete the add API annotation because it doesn't apply to our case. So add test template annotation is applied to the add invoke twice annotation, but also add extend with annotation with invoke twice extension.class is applied to add invoke twice annotation. Let's review the add test template annotation, and being in the reader mode, you can read more thoroughly what this annotation stands for. You will see that it's a test template annotation. It's annotated with testable, which is basically the very basic annotation of JUnit. You can see that it's from JUnit version 1.0 that suggests, or rather specifies, that a certain element of the code is testable. That it can be a test or a dynamic test, etc., etc., or in our case, a test template, etc., etc. Alright, so this is a test template, and it is used together with @extendWith. In our case, we implemented the invoke twice extension. Let's take a look at this extension. And invoke twice extension implements the test template invocation context provider, which is a requirement. The test template invocation context provider is an interface. Let's take a look at it, which extends extensions. So it signifies to the JUnit 5 runtime that this interface, once implemented, signals there being an extension of the runtime of the platform. And it has two methods which must be implemented: supports test template and provide test template invocation contexts. Right, let's take a look, and you can utilize the reader mode to read the Java doc further. But let's take a look at our implementation of the test template invocation context provider. So here, stating whether or not it supports test template annotation, we return true. So we're basically stating that this whatever we apply it to is a test template. And in here, we are supposed to provide a stream of test template invocation contexts. And we just provide two of our custom invocation contexts, which we call invoke twice invocation context. So let's take a look at the test template invocation context. This is just an invocation context, which says get display name, and then returns additional extensions that also can be invoked once this test template is invoked. This is a very powerful context concept, because it can allow you to create by building together a very complex functionality. Alright, having taken a look at test template invocation context, let's take a look at our implementation of it. We basically just implement the get display name, because remember, all these methods are default. So what we're doing is we're selectively overriding one default method. We get the display name. It will return the run number and invocation index, which is something which is supplied here. Alright, and we're returning it 2 times, so we would expect it to be returned twice. Of course, by getting data from extension context, we could create something fairly complex here, such as a parameterized test, for example. But for the purposes of the course, we need to keep it illustrative but relatively simple, and that's what we're doing. So we would expect the invoke twice extension to cause whatever method we're running to be run twice. And let's take a look if that's the case, in fact. So just to add one more thing, test template must always be used with the @extendWith and whatever extension we supply. Alright, let's return to our main. Let me take a look at something else. Okay, since we have a test template, we do not need to provide @test annotation here, I don't think. Let's run it and let's see what happens. All right. So we see that the runtime ran this unit test method, and it ran it 2 times, run number 1 and run number 2. If you recall, that is exactly what we wanted to see here. When we overrode the get display name, we returned run number invocation index. So the invocation index we got is 1 and 2, run number 1, run number 2. So that is how we implemented the add invoke twice annotation, making use of the add test template and add extend with paradigm, allowing us to create from simple to very complex test templates of how the JUnit runtime will process different types of how unit tests must be run. For example, add parameterized test is an example of a combination of add test template and add extend with annotations. All right, so let us go back to the our main test class, and let's fix everything here, and let's try to build it and see if everything builds correctly. Alright, everything is fine, and we are ready for our next video clip. In the next video clip, we are going to, obviously in these video clips we've been making heavy use of the add extend with annotation, but there are 2 different other ways to register an extension or a series of extensions. And in the next video clip, we are going to take a look at the add register extension annotation. Alright, so in this video clip we're going to take a look at the add register extension annotation, but first let us correct something that we neglected to do in a previous video clip. Let us go to strings test.java and let's uncomment the test at line 48, and let us comment out the test directly following it. Alright, having done that, I think we're good to go. Let's see that all the tests now pass as they should. And if they don't, we have to fix it. Alright, and we are good to go. Now let us transition from strings tests.java back to objects test.java to line number 20. Let's comment excuse me, let's comment out the add register extension and the following lines. Static not funny method extension, not funny message extension, not funny message extension equals new not funny message extension. So why have a second way of registering an extension? Well, simple. In addition to add extend with, which does not allow us to configure an extension in place within the same test class where it is registered, add register extension allows us to do something like that. For example, if we are declaring a static variable, we could configure it within the static block of the Java class. if we are declaring an instance variable, we could configure it within, for example, the constructor. Alright, so let's see how the add register extension works. But for that, let's take a look at the not funny message extension class within our auxiliary project. It is basically a very simple extension that implements after all callback, which is a type of extension, if you recall. And it implements the after all method and just basically logs that did this test class or nested class fully pass. Let's go back to our main project and let us actually run the objects tests test class. And there we go. However, you will notice that it was invoked 3 times. Why was it invoked 3 times and not once? Well, I'll tell you, because it was invoked for is not null, is null, and objects tests. Right? So now we see that basically we did register the extension. The extension ran fine. But what if we, and it also, because we registered it as a static variable, it applies to the test class itself. But what if we wanted to, for example, register it twice? Well, in that case, just like with multiple same lifecycle methods, the JUnit runtime orders it internally in a non-obvious but a certain order. We are not privy to that order. That order is the same from invocation to invocation, but we don't know what it will be, and there is no good reason to try to delve into it. Because if we want to order these extensions ourselves, we have to use the add order annotation. For example, like this. So then we will know that this will be registered first, and this will be registered second. And of course, they're going to be registered after JUnit 5's built-in extensions. Alright, so let's delete this. Just keep in mind the existence of the add order annotation and its applicability to this case. Now let's uncomment the code at line 23, and let's see that we indeed are registering an extension from the not funny method message extension, but we are not using a static modifier, so it's an instance variable, and that means that this extension does not apply to objects tests, but it applies to the methods, to the instant methods of this class. So to these 4 methods. So basically, this instance extension applies to unit tests. And let's take a look actually at this extension in its natural habitat within the auxiliary project. Not funny method message extension. You see that we are actually implementing after each callback here. And that's if we are declaring that register extension class, if we are declaring it as an instance variable, we are really constrained to unit test level interfaces. So if we, for example, implement after all callback, it won't be invoked here because we registered it as an instance extension. Here, however, we could register unit test level interfaces, implement the methods, and it would not only apply to the test class itself, but also to its unit tests. So if we declare it as static, we are more versatile in how we can operate this extension. All right, so let us go back to the main project, and let's actually run objects tests. All right, we have did this test method pass, did this test method pass, did this test method pass, and did this test method pass. So it was invoked 4 times this extension for the 4 unit test methods, and we can see it here. Right, and last but not least, the objects tests not funny message extension got invoked in the very last action here. All right, and again, if we decided to register several of these, well, different ones, of course, then it would be a certain but non-deterministic order, and we would need to use the order annotation to specify the order in which to run this. And I apologize. Okay, no, it's okay. Let me also do this. So this would run first, and this would run second. All right, and it also is registered after JUnit 5 platform's built-in extensions. All right, this concludes our treatment of the add_register extension method of registering extensions. Let's comment it out. Let's rebuild it just to see that everything runs well. All right, and if we run objects tests now, we will see that these extensions are no longer registered, and we don't get that nice log output that we used to get. All right, this concludes the add_register exception. add_register extension treatment of this particular way to register extensions. In the next video clip, we're going to explore the service loader mechanism of the Java virtual machine, in which case we can register extensions automatically. In this video clip, we're going to explore the extension service loader mechanism, which is available as a third method of registering extensions. It's actually the method which registers extensions automatically and registers them after JUnit 5 platform's own global extensions that are auto-registered. So in order for that to enable the service loader automatic extension registration, we need to do one thing. We need again to create the JUnit platform.properties file, and if you already have it here, please delete the version which you have, and we're going to do it anew. JUnit-platform.properties file, Here we have it. Let's go to the project website. Let's go to unit test code, object test.java, lab 6. Scroll all the way down to JUnit-platform.properties. Copy it and paste it into the appropriate file. Now go to line 24, uncomment it, and change the value to true. JUnit.Jupyter.extensions.autodetection.enabled must be equal to true for the service loader mechanism to work. Now let's take a look at the library that we have, the jar library, which we have GRG-001 JUnit as a habit extension. Let's take a look within its meta-inf folder and services folder at the org.JUnit.Jupyter.API.extension file. And we see here that we have a funny message extension class in here. All right, let us close it. Let us go to the auxiliary project and let us take a look at this class, which is in the service, in the tag.getRealGood.util.service package. So basically it implements before all callback, and it just basically outputs an info message. What am I getting myself into here? So this is what we must see when we run our unit tests with this automatic service loader mechanism enabled. And let's actually run our objects tests and let's see if that's indeed the case. All right, and here we have it. What am I getting myself into here? I remember we implemented the before all callback, which is going to be applied before it nested inner classes and before the test method itself. All right, so it worked beautifully. And we have automatically registered an exception, which is registered after JUnit 5 platform's global extensions, which are registered, auto-registered by default. Now let's look at one more thing that we would like to do. Because, for example, let's go to the meta-inf services extension file. And we see here that on this line we have tag.getRealGood.util.service that funny message extension. But what if we wanted to register more than one extension here? Well, just put it each one on a separate line. For example, if we wanted to register ext not funny message extension. So we have now extension which will be registered first and extension which will be registered second. Let's now build artifacts. Build. Let us go back to the main project and let us run. Well, first let us take a look at this file, and it will have two lines in here. Let us now run objects tests.java and see that both extensions are present. All right, so we have the funny message extension, and then we have the not funny message extension. And we have the funny message extension and not funny message extension. And they're a little bit mixed, but basically the first one runs, let's take a look. They're mixed because of the particular way the logger outputs its output, but the first one implements before all callback, and the second one implements after all callbacks, so you would expect that each of them would be called exactly 3 times, which we have 1, 2, 3, and 1, 2, 3. Basically we have 2 nested inner classes, and we have the top level test class. So that it works as it should. Let's now clean up what we did. Let's delete the second one. Here, let's rebuild the artifacts so that this jar library is available in our main project. And let's take a look. Well, let's wait a little bit. Let's see if it built it. Synchronizing output directories. I think we should close this. And we should maybe rerun it. And let's actually rebuild the project. And the artifacts are going to be built as part of this build. Right, that was successful. Let's go back to some lock-in issues between this project. Let's go back to metainf, and we should have one file here, which we do. Alright, let's go to objects tests. I think we have everything correct here. Let's build our project, and then let's run the unit tests to see that everything is in a pristine and original state. Alright, let's run all tests. Alright, all of them pass. Now, last order of business, let's go to the JUnit -platform.properties file, comment out this line and change it to false as it originally was. Alright, we have seen all ins and outs of various extensions, of various ways to declare extensions, and we are very close to concluding this lab, except we are going to have some more content rehashing the different types of extensions, and of different types of declaring extensions, because this is a tremendous amount of material, and in order to impress it into your mind, we're going to do one more thing that I think you will like. JUnit Extension Model Lab 6 Rehash. During the course of Lab 6, we explored the following types of extensions. Extensions which interact with one another by utilizing extension context.store interface, for example, type timing extension and method timing extension. Extensions producing custom test class instances, for example, test instance factory implementations such as loggable objects tests factory. Extensions intercepting various lifecycle unit test, test template dynamic, and test instance factory methods. Invocation interceptor implementations such as test invocation interceptor. Extensions firing methods based on the status of a concluded unit test, such as whether it succeeded or not. Test watcher implementations, such as test results watcher. Extensions enabling or disabling unit tests, execution condition implementations, such as enable method execution condition and disable method execution condition. Extensions resolving and injecting parameters from from elsewhere into constructors or unit tests. Parameter resolver implementations such as method parameter resolver. We also explored annotations we had deferred from Lab 5, namely the add test template annotation, which must be paired with the add extend with annotation and can produce non-trivial unit test running patterns. For example, it is the basis for the add parameterized test annotation. We also explored the 3 different ways of registering extensions with the JUnit 5 runtime, such as by using the add extend with annotation, by using the add register extension annotation. Of course, we can register variables as static variables or instance variables with that one, and by using the service loader mechanism of the JVM. Remember, extensions are inherited in the top-down semantics within test class hierarchies. For example, test class level extensions are inherited at the unit test level. An extension can only be registered once. Duplicate registrations are ignored. Last but not least, the JUnit 5 platform auto-registers some built-in global extensions, such as support for test info, support for test reporter, and so on. So, Lecture 7, the last one, is next. Keep up the good work and thank you for your attention. Please do not let it diffuse.